Hello, this is Dr. Y.S. Rao. In the previous session, we have discussed about sensors, which are switch infrared sensors. Both the sensors are digital type of sensors where their output is only two states, either high or low. In this session, we will discuss about analog sensor, which is which the sensor's output voltage will change based on the physical parameter. So the sensor which we are talking is light dependent resistor, LDR. You can see light sensor, the brown colored zigzag type printed line sensor is here near to 21. So this sensor is an analog sensor where one side of the sensor is connected to 5 volts, other side is connected to ground through some biased resistor. So based on the intensity of the light, ambient light, not infrared light, ambient light, you can use your torch light, mobile phone light to change the output voltage. So based on the intensity of the light, the output voltage will change. So this sensor we will is connected to A to D converter of this microcontroller, and we will read that value. Either we will display it on LCD, or we will display it on serial terminal, computer terminal, or we compare that value accordingly. Some LEDs or some buzzer, something will be you can make it on and off. So let's see how to do the programming. Now this sensor LDR looks like, right, this shape, covered, fabricated with a ceramic material, and two electrodes are there, right? You can see the aluminum wire terminals. These electrodes are nothing but is a photoconductive material which is coated on a ceramics substrate. So this photoconductive material, right, act as a electrodes where the material property is such that if you throw some light on this material, as you can see, as the intensity of the light is increasing, the resistance of that particular between these two leads is decreasing. Initially it may be mega ohms. As the intensity of the light is keep on increasing, it will come down to kilo ohms and ohms, right? So resistance will decrease if the intensity increases. So how do we use this in the circuit? Let's say, for example, you have, right, one side, like I was telling, let's say there is a circuit. One side it is connected to 5 volts, other side, let's say, connected to some ground. So based on the, as the light falls, the resistance, you can see few ohms to few kilo ohms or mega ohms, it's keep on changing. So this may cause, this change in resistance may cause some change in potential that may lead to change the output of a circuit. So this principle we also use in our system, right? So let's write a program for that. So the the program, right? So if you see the projects, what is said as a CDS sensor, first program. Now, like I was telling, this sensor is an analog sensor. So it now in the program, when I'm using first, I want to display the value intensity of the light on the LCD. Let's use the LCD component. And in the first line, it will display like ambient light, right? Some text. Let us put it in the while loop. In the while loop, unconditional, right? True means infinite loop. Then in the while loop, first LCD, what we are saying is, right, define, right? You say output variable is, we would like to read that. See, there are several possibilities of reading. You can also define some constants. You can also read the value of the left motor count, right motor count, right? Or the sensor values, bottom right, bottom left, bottom center, front left, front right, front center. Similarly, you can also read the infrared. In future, we will see infrared sensor, which is a TV remote sensor. All these things are your variables. In this program, the variable which we are using is a LDR value, right? Light dependent resistor value. This we would like to read. And then, so what we are saying, that first line is a ambient light, and in the second this thing, that value will be displayed, and then clear the screen and be in the loop for 200 milliseconds and repeat this again and again. So as and when the intensity of the light changes on your LCD, this parameter, output parameter, will be changing. It will be displayed. So let's see how it works. So two things we have used in the program. One is LCD we have used because we want to display the number of the intensity. Second, we want to display the LDR. So when LDR is nothing but it's a variable, right? The variable we have chosen, you can see, is not a text, it's a variable. That LDR value we want to display it, right? So select the LDR value this way. LDR value will be displayed. So program it. Now programming is done. Now what you can see, that on your LCD, the first line, this will be displayed ambient light, and in the second line, actual based on the intensity of the light, right, the numerical value will change. Alright, so as per the program, the first line is LCD initialization, and then first line what we would like to display 0 comma 1 is LD first line, sorry, here is XY is 0 0, ambient light will be displayed, and in the infinite loop LDR value should be displayed. So if you look at the results, what it displays is first line, it displays the ambient light, second line corner single digit it is displaying. If I try to cover this, okay, the value is decreasing. If I uncover this, the value is increasing. Now you can see. All right. So if you carefully look at the program, what we are trying to say is, the when you say LCD, here the variable, right? We, instead of text, we selected our LCD output type is a variable, and since it is a variable output, we didn't put any output text here. We said output variable is what variable you want to display. Now you can choose various characters, integers, long integers, constants, and so on. Also, you can display some sensor values on the as a variable, output variable, like bottom left motor count, right motor count, means how many rotations the vehicle wheel has rotated. Then below the PCB we have sensors. Those values can be displayed: bottom left, bottom right, bottom center, front left, front right, front center, left motor count, right motor count. So at least in this program we are interested in LDR value. In future we will see infrared sensor, TV remote sensor also. That time we will say IR input, LDR value we want to display. So that's the reason where that analog value, it is reading, which is a two digit, that is 8-bit number, 2 to the power of 8. Maximum it will display 255, minimum 0. So based on the change in intensity of the light, the corresponding numerical value it is displaying as a output variable. That's about the first program, where we have used LCD as a display unit and input sensor we are reading from LDR. Let's see the second program. In the second program, instead of using the LDR, we are using UART as a component. Now this UART component, when you select it, again you can see what are the possible types of output types. It could be variable, it could be new line, it could be text. Right now we want to display some text, so that's why text is selected. Now since it is a text, what kind of output text you want to display? That whatever you want to display, you type it. So that text will be displayed here. For example, you say LDR, let's say value. So whatever you type will be displayed here, right? Then again the same component we are using. This time nothing we want to display but new line. New line means on your computer screen, the next text will be displayed in the second line. After that, we are in the infinite loop. In the infinite loop, first again UART text we have selected, some text we have displayed. The second UART we want to display. Now this time variable we have selected, not the new line, not the text, variable. Now, so that's the reason output variable we have to select, right? Not the output text. The output variable, what variable you want to display? You have so many variables, all the sensors, but LDR value you want to display. And again we have used UART component, but this time new line. Why new line? Because next time when you repeat it, the value should be displayed on the new line, right? And delay means wait for some time so that it will kill, right? How much time you want to kill? Microseconds, milliseconds, seconds. So you want to kill 200 milliseconds. And it's in the infinite loop again and again, because while one means true. True means this condition is satisfied, so it will never ever come out of the loop while one. And whatever is there inside the loop will be executed infinite number of times. All right, so let's program it. Programming is done. You can see the ready status. Now where will you see the results? The results are communicated through serial communication, UART. Right? What is serial communication? This cable, through this cable it is transmitting the data. Maybe in future courses we will also transmit the data through Wi-Fi, Bluetooth, and so many wireless communications are also there, that we will see in some other courses. Here we are transferring the data through wire serially. So that is coming to the computer now, right? Now this data is coming to the computer. Where will you see the data on the computer? Go to tools, serial terminal. Okay, now serial terminal is selected. What should be the baud rate? Same baud rate, 57,600. Why? Because in the program also, right? If you see in the program we have selected 57,600. So that's the reason here serial terminal you should select the same baud rate, 57,600. And then clear the previous text. So clear console, nothing is there. Now connect to the QU board. That means it has to communicate to the QU board. So connection is done. As soon as the connection is done, now you see whatever we said LDR value, it is displayed. Then the second, it is displaying ambient light intensity. Now if I try to cover the LDR, now see I have covered the LDR. See the value has decreased, right? Now if I uncover, the value is increasing. So the somewhere between 0 to 255 the value will be seen. And why it is displaying on the new line every time? because in the program we have also used the command UART new line. So that's why next value, new value is displayed on the new line. All right, so that's the interpretation. So you can also modify, right? You can add your own components and do that. That's the second program. Let's look at the third program. So far we have displayed the values, LDR value, either on LCD or on the serial terminal, means computer terminal. Now in this program, we are not interested in displaying the value. We are interested in comparing the value, right? So in the while loop, you see infinite loop, if the if conditional statement we are using to read the LDR value. As you can see, this if conditional statement could be, we have earlier used for infrared sensor switches. This time you can also use it for motor, because motor is also having a sensor, that optocoupler, right? This infrared sensor is there to count how many rotations it has rotated. So this time we are using if conditional statement to read the LDR value. Now see, if I select this conditional statement, now you can also choose the various operators. So what do you want to do? Conditional statement equal to, less than, greater than, not equal to, less than, equal to, greater than, equal to, like that you can choose the conditionals. This time we are chosen below, anywhere below 100. So even the count value also you can change, LDR value. What is the value? You can go up to 255. All right, so if this condition is satisfied, then what do you want to do? This LED should be blinking, right? Toggle. You can also use buzzer, motor, whatever you want to do some action, you can do that. Here we said, okay, the selected output value is that LED 1, you want to toggle it. Else means if this condition is not satisfied, the something else we want, the same LED 1, we want to make it off. And this is conditional statement is terminated, this loop is terminated. Then delay means wait for some time. Now you can choose the how much delay. And since while one is a infinite loop, it will never ever will come out of the loop. Otherwise, if this while one is not there, it will come to the end statement, and the buzzer, the end means the buzzer will be on for some time. 3 beeps you will get generally. But in this program, it won't come to end statement. It will again go back and will keep on reading the LDR value. So let's program it. Now programming is completed. Now it is ready. Now in this case only LED, right? We have chosen a LED. So if you see the LED 1, now I will try to cover this thing. Now see, the LED is blinking. I have covered this LDR, light dependent resistor, this first LED. When I have not uncovered, the value is more than 100, so nothing is happening. But if I cover it, the value has come down less than 100. Now this toggle means complementary to the previous state, on off, opposite in nature. So see, LDR I have covered with my finger, the LED is blinking. And if I remove the finger, the condition is not satisfied, the same LED 1 is in the off state. Alright, so that's about the program number 3, where we are comparing the value and taking some decision. As you know, instead of LED, you can also switch on some bulb or some appliances, right? Street lights and so on. Or you have seen how the air conditioner is on and off, washing machine is on and off, geyser is on and off. So these are all have sensors, analog sensors, and they are reading continuously the physical variable and is converted into electrical signal. Then the electrical signal is converted to a number, analog number, means BCD number, which is ranging anywhere between 0 to so and so number, let's say 255 in case of 8-bit. Then you can write a conditional statement, compare, take some decision, and that decision could be your choice, LED, motor, or some other actuators. Okay, so that's about the example number 3. Example number 4, where more or less same, only difference is in the infinite loop. If LDR, when you are using the operator, three places, if, else if, three times we said conditional statement, and in the condition, right, again you can choose, right, your variable you have a choice of choosing, operator you have a choice of choosing, value you have a choice of choosing. So all these things you have choice. You can choose what conditional statement you want, value you can choose. Once the condition is satisfied, then in the bracket, what are the action, what are the set of events you want to execute, you can specify. Here you have used three LEDs, LED1 off, LED2 off, LED3 off, if the value is less than 60. Also, we are using UART component, and it will display on your computer screen saying that ambient light intensity is level number 0, and it will insert the new line because next time you want to display it on the second line. If this condition is satisfied, means 120, below 120, first LED is on, second and third is off, the text is something else, level 1 it will display new line. You have third conditional statement. You can keep on adding as many as you want, even small numbers also you can compare. Then this here you are saying two LEDs are on, third is off, and on your computer terminal you are saying ambient light intensity is level 2. Again a new line. If none of the conditions are satisfied, else, here you are not verifying any condition, just else. So in any case this will happen. That means LED1, LED2, LED3 is on, and level 3 will be displayed new line, and it's a terminated. Means if these three are not satisfied, that means this will be satisfied. And wait for some time because we want to delay it, and it's a infinite loop. So in this program, two ways we are verifying the condition. One is after comparison, we are showing the status on LEDs, three LEDs, because three different numbers we are taking, 60, 120, 185. You can change as whatever the number you are interested. And then we are also indicating through serial terminal that we are not interested in the value. We are saying, okay, level 0, level 1, level 2 has happened, like traffic lights, like that. Any one of the condition it has to satisfy. So let's program it. Now programming is done. Now it's ready. Now if you see the results, we are not using any LCD here. We are using LEDs. Now as you know, this LDR, now you see I have covered the LDR. That means the value is less than 60, so none of the LEDs are on. If there is a more than 60, now slightly I have covered, first LED is on, I have removed the hand, second is on. Now all three LEDs are on because all the conditions are satisfied, right? Otherwise if I cover it, you can see some of the LEDs are getting off. So it is up to you. That is called calibration, with what numbers you want to compare. Accordingly it will take the decision. Okay, so this sensor and output. However, in the same program, we also use the serial terminal because UART we have used. Means we want to transfer the data to other computer. That's called computer communication. So that facility is there in tools, serial terminal. So what is the baud rate we have used? 57,600. So in serial terminal, use the same baud rate, that is 57,600. See, both should be same. In short, please remember, whatever you have used in the program, the same baud rate should be used here. That is called speed, rate of communication. Means how many bits per second you want to transfer. Now clear your earlier data, connect to your QU board. Connection is done. As soon as the connection is done, now you can see the whatever the text message, it is keep on displaying. Now if I cover the LDR with my finger, now you see level 0 it is displaying. But if I remove my finger, and I can see level 1. If I fully uncovered, level 2 or level 3 based on the intensity of the light. That's how you can verify. You can read the LDR values, Instead of LDR, in future you can also use some other sensors. In other cores we will see there are 30-40 sensors are there, right? Generally students do lot of projects based on various sensors, various applications. So we can use such kind of sensors in other cores, and take some decision, some action. Sometimes action, sometimes actual value we want to communicate to other system. Like for example, you have a Fitbit, you have a watch. Your watch is measuring your blood pressure or how many steps you have moved. And it's not only displaying there, it is also communicating. The watch has the ability to communicate on your mobile phone, right? If you pair them, so there, how do we pair them? Maybe we use Bluetooth, Wi-Fi, then data transfer takes place between the two devices. Nowadays, the same thing is also can happen on the cloud platforms, means some other computers, servers. So there also, that's the reason nowadays all these branches, right? Data science, artificial intelligence, machine learning, data analytics. Why these branches has come up? Because all these sensors are collecting the data, but the data is such a huge data, you cannot store it in your mobile phones or in your the microcontroller boards. So we put it on the cloud platforms. What is cloud platform? Cloud is a data center which has a servers, huge amount of data storage, hard disks are there. That's why even communication like UART, USB, Wi-Fi, Bluetooth, communication is also important to transfer the data. Alright, that's about the fourth program. Let's see about the fifth program. Fifth program, there is no much difference. Same conditional statements, three times we have used. You can change the values if you want. Instead of LEDs or UART, this time we have used the motor, so that if this condition is satisfied, a specific motor can move. You can choose which motor, move forward, move backward, move reverse, with what speed the motor should rotate, that also you can specify, and that action will take place. If you do not mounted the motor, then instead of motor you can put a buzzer. The buzzer will be on whenever this condition is satisfied. So all options are there. I think you should try all possibilities. The beauty of this program is you are actually defining the variables, and the variables also you are comparing, right? And by using operators you are verifying, right? And then you are taking some decision, and the decision you are conveying by using LED, LCD, UART, motors, buzzers, and so on, because these are all outputs. So the same program you have used inputs also, outputs also, and some communication devices also like serial communication. All right, so in short, this is all about the light dependent resistor, which is the sensitivity of the sensor is based on the intensity of the light, where the photons, right? The light means photons. The photon energy is making the resistance to change. Resistance is decreasing. The resistance decreases, then we have the corresponding change in the output voltage. That output voltage is given to the CPU. CPU is converting. There is a peripheral called analog to digital converter, which is converting into 8-bit number. So somewhere between 0 to 255. So that variable we are reading, and we are comparing and taking the necessary action. So this is the advantage of using analog sensor, because we can quantify. In earlier sensors, they are digital. They only give either 0 or 1, no intermediate values. Alright, so that's the difference between analog sensors versus digital sensors.